Welcome to This Explainer. Today, we're going to turn Chapter 13 into a completely fascinating mathematical safari. Seriously, if you've ever wondered how numbers actually relate to each other out in the wild, you are exactly in the right place. We're going to unpack some core math concepts, things like factors and multiples, but we're going to do it by tracking animal jumps and navigating jungle trails. Sound fun? Let's get into it.
Okay, let's dive right in with a bit of a mystery right out of the gate. Picture this. You drop a number into a magic box, and a completely different number pops out the other side. What kind of mathematical operation is happening in the dark in there? Can you guess the multiplier?
Now, what's really interesting here is looking at the numbers coming out. We've got 28, 36, 48, and 72. So based on our source text, if we work backwards, could the secret multiplier hiding in that box be 1? Well, yes. Could it be 2? Absolutely. How about 4? Actually, that works too. It turns out there's way more than one possible multiplier that could create this specific set of numbers. To figure out exactly what these multipliers are called and how they work, here's our roadmap for today. First up, the magic number box. Second, arrays and prime numbers. Third, jumping to common multiples. And finally, number 4, Mowgli's Jungle Trail. All right, let's kick things off with Section 1, the magic number box, uncovering the secrets.
So the crucial point here is that those hidden multipliers we just guessed, 1, 2, and 4, are actually called factors. A factor is simply a number that multiplies with another to get a specific product. Since 1, 2, and 4 perfectly multiply into 28, 36, 48, and 72, they are factors of those numbers. And because they work flawlessly for all of them, our source notes they're known as the common factors of that group. Makes sense, right? Moving right along to Section 2, arrays and prime numbers, visualizing the building blocks.
This is where math stops being just, abstract ideas in your head and becomes something you can actually see. Take the number 12. You can arrange it into different visual grid patterns, which we call arrays, to easily find all of its factors. First, arrange 12 items as 2 rows of 6. Boom! 2 and 6 are factors. Rearrange them into 3 rows of 4, and you've just revealed 3 and 4 as factors. Finally, make one long row of 12, giving us 1 and 12. So the complete list of factors for 12 is 1, 2, 3, 4, 6, and 12. Basically, if you want to know a number's factors, just see how many perfect rectangles you can build with it.
But what happens if you can't build those neat little rectangles? Try making multiple arrays for numbers like 13 or 37, and you're going to hit a wall. You can literally only make one single row of 13 or one single row of 37. You'll find they are prime numbers. This means they completely break the array rules and have only 1 themselves as factors. They are basically the lone wolves of the number line.
Okay, let's jump into Section 3, jumping to common multiples, the animal race.
Now we're shifting gears from factors to multiples. Let's head out on the trail and see how this works in action. Imagine a frog taking a jump of 3 spaces each time, and a rabbit taking a jump of 4 spaces. If they both start at 0, they're obviously going to land on very different spots at first, right? The frog's track goes 3, 6, 9, while the rabbit's track goes 4, 8.
But when we map out their footprints side by side, something fascinating happens. Look at that overlap. We discover that the very first spot they both land on is 12. The frog gets there in 4 jumps, and the rabbit reaches it in 3 jumps, but their tracks finally cross at that exact spot.
And that perfect overlap, that gives us our definition for a common multiple. It's the exact overlapping number that both animals will touch on the number line. See, when you multiply a number by anything, you get a multiple. But when 2 completely different sequences hit the exact same multiple, they have a common multiple. So 12 is the very first common multiple of 3 and 4.
We can test this out with other animals too. Let's compare a spider jumping by 3s and a grasshopper jumping by 6s. The spider lands on 3, 6, 9, and 12. The grasshopper lands on 6, 12, and 18. Notice how 6 and 12 become their common multiples. In fact, because 6 is already a multiple of 3, the grasshopper is literally landing on the spider's tracks on every single jump.
For our final leg of the journey, it's Section 4, Mowgli's Jungle Trail, navigating with math. Let's use what we've learned to safely guide Mowgli through the jungle. According to our source, if Mowgli takes jumps of exactly 2 steps starting from 0, he perfectly lands on spaces 4, 12, 14, and 50. Now, why does this specific jump size work so perfectly for visiting his friends?
Well, because 2 is a common factor of all those locations. Since 2 divides evenly into 4, 12, 14, and 50, a steady 2-step jump will always land him right on their doorstep.
But listen, math isn't just for visiting friends. Out here, it's for survival. We can actually predict danger on the trail. If Shere Khan the tiger hunts every 3rd day and Bagheera the panther hunts every 5th day, and they start on the exact same day, finding their common multiple tells us exactly which days they hunt together. By looking for the common multiples of 3 and 5, like 15, we know exactly which days the jungle is twice as dangerous.
So, tying it all together, a common factor is a number that can perfectly divide 2 or more numbers with absolutely nothing left over. No remainders, no half-steps, just a perfect mathematical fit, exactly like Mowgli's jumps hitting his targets.
We can even categorize our remaining jungle numbers to find the ultimate common factors of 2, 5, and 10. Look at the first column. Numbers ending in an even digit are perfectly divisible by 2. In the middle, numbers ending in 5 are divisible by 5. But look at that last column. Numbers like 30, 40, and 90 end in 0, meaning they are perfectly divisible by all 3. 2, 5, and 10 are all common factors for those specific numbers. It's like hitting the mathematical jackpot.
Well, we've covered a ton of ground today, from magic number boxes to tracking jungle predators. I'm going to leave you with this final puzzle, straight from Chapter 13, to solve on your own. What single jump size lets Mowgli safely visit both Kaa the snake at space 21 and Akela the wolf at space 35? Think about it. You're looking for a common factor between 21 and 35. Grab a number line, map it out, and see if you can guide him safely. Good luck, and thanks so much for exploring this with me today.